Here we go. This is a video about a project finance modeling. This is a technical video. Please, it might be torture for some people, so um, I'm going to introduce it a little bit, and it's going to be about incorporating actual balance sheet numbers kind of in the middle of a construction period, not kind of, in the middle of a construction period on a project finance model. So if you want to find this model, you can go to the project finance modeling on A to D, A to Z, and then in the Google Drive, it's not going to be there yet, but it'll be in folder number B. Here's the little introduction or standard warnings. Everything this is a torture video, and I'm a student, and I haven't done this before, so I haven't done any of this stuff before, and I'm trying to. This is about a class. It's about a follow-up for a class, so it's kind of out of order. If you want to watch it, good. If not, please turn it off. We're going to talk about building a model and using circular references and getting quarterly analysis or quarterly statements from monthly statements, and most importantly, how to use a historic switch. So if you have in the middle of you're building a nuclear plant. This was a nuclear plant for 100 months or something. In the middle of it, you have some actual financial statements with actual debt, actual work in progress, and all that. How do you put those into the model so you reflect both the actuals and the forecast? Here's what not to do. If you do this, you don't manually kind of just overwrite stuff in the model. That's what I've seen too many people do. And so I'm going to show you kind of how to avoid that with a switch. Okay, some of the stuff's pretty simple, but some of it, frankly, was much more difficult than I thought it would be. Okay, so let's say we've received some balance sheets, and we want to change the date. We want to make it real flexible, so you receive a balance sheet this quarter, next quarter, next quarter, and how to see how it works. Okay, so here, let's look at the file for a minute. Okay. All right, and right now, I have a actual here. Sorry about that. We have historic financial statements till December of 18, and then we have a forecasted financial, and then we stopped construction in 2022. Okay, we have our standard dates, and we have an EPC contract. Okay, why did I say that so loud? Here's why I said it so loud. When we put our actuals in, and we're going to have some, I just switched the page, so we have some actual work in progress, actual IDC, actual loan, and actual equity in the balance sheet. Balances, it better balance. If it doesn't balance, what can you do about that? Okay, and then we're going to put our actuals in the model somewhere down here. Okay, here's where I put the actual data. It was I assumed it came in a quarterly format, and I had to interpolate, which we'll talk again about later in this video. And then this is kind of the deal. When you make a forecast, we'll adjust our actual for the forecast. So by the very end, blah, 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 it just comes, we just did it. We get exactly 1,000 in our balance of the construction. And more importantly, we decided we're going to make a loan of 80% debt to capital, and then we go through all of our funding needs like we do in a kind of normal model. I keep saying kind of. And then we see how much we need to borrow or not borrow in order. This was an extreme case. I'll fix this to another case. Just a minute. Okay, and then how much we have to borrow so that by the end of the project we're up to our final loan balance. So the idea is to have some actual data. I put little things here into to have some actual data and see how that data, how the actual plus a forecast eventually gives us our target debt to capital ratio and our total project costs. So this is kind of an illustration here. We had some actuals that I guess were lower than the forecast, and I made two different kind of historic scenarios. So in this case, they were actual, and by the time we hit our actual, I mean the last actual date, then this is what we had originally forecast. Then we have to spend more than we originally forecast. So by the end, the integral, the stuff below these two lines, is exactly the same. Okay, and we can do the same with the debt balance. We have some debt that's on the balance sheet, but by the end, we issue more or less debt. So we're just at the debt to capital ratio we begin with. I don't know what I did here. I'll explain kind of how I put these hypothetical things in. So that's the issue, that's the idea of the model. And you can do it all very automatically. So let's begin. Well, no, let me do something first. I have not colored this. Now, I put another version of generic macros up on the thing, and if you do this, do you see where it says clean conditional formatting? I'm not going to clean the formatting. That means every time I press the color sheet, it adds a new conditional format thing to it. Okay, and then I'm also going to color the historic. So here's our kind of input data. We input the debt percent and how much is pro rata and how much is up front. Thanks to Heidi. And I'm going to also make a little, let's select this whole thing, and I'm going to make because we're talking about the actuals, I think I should make the actuals a slightly different color. Now, when you do this, it's probably a little bit of a good idea to make a range name. I put new rule, use a formula, and then, of course, I keep saying this, but you have to go all the way to the top left with the mouse. No. No arrows. You have to use the mouse, and we'll put the $ only on the 6. I'll put equal true. I don't really have to do that. And then we'll format the historic data as kind of some other color. I'll make it as light as I can. Okay, so, maybe not so good, but I'm going to leave it for now. Okay, and then so now you can see, well, for these data, we have some projected, it says projected, I should say projected / actual construction. So how do we get a series that in the historic years reflects the actual from the balance sheet, and then when we go forward, it reflects the projection that's just enough to, I can't get words out today, that's just enough to match our total from the actual balance sheet. And then we go through our standard sources and uses statement, and then we make our funding needs as usual. And when we get to the debt funding, we put this is again an actual, and once we have the actual, then after the actual is finished, we put the whatever percentage debt, I had to put in this case it's extreme, in order to make the debt to capital ratio just equal to our 80% when we're finished. So I'm going to go through the PowerPoint slides just a minute. Okay, so the first issue really to discuss is just general structuring of project finance model in the construction period. Now, some of the absolutely essential things is, of course, we put constructions, which is, I don't think, if you haven't looked at some of the fundamental videos, there has to be a construction flag, but also a switch for when we're on the historic period. Then we need a sources and uses of funds statement, and one of the big reasons you need this source and use of funds statement. So here we go. Here's our flag, or switches, or flags, or whatever you want to call them, and some normal kind of dates, and then of course we have a little if statement for the various dates, and I'm going to come back to that end of quarter in just a minute. Some financial variables, and then we have our construction section, and then it's essential to put a summary sources and uses. Here's the total EPC cost, and then we need to use this total cost to see, we're going to need this to adjust the debt. There's going to be a big circular reference around all of that. And then we need all the debt numbers, because we're going to use all those debt numbers. Here's where we use the remaining cost. We need to use the total debt to see how much is left over that we still have to finance. We need to know the total equity to see, in part, to see how much we're going to finance up front. And then when we go to the debt schedule, we need to know our debt commitment for our upfront fees and our commitment fees and all that. So it's absolutely essential to be able to fill these little numbers in our wonderful columns to the left. So so we can be a little transparent, okay? And then what I did is put a little Weibull curve here, and that just says, okay, well that's just how we kind of make this curve for the construction. We can push it forward here, we can push it backwards. This is an S curve, because if you accumulate, it'll kind of look like an S, so we can have a very flexible construction schedule. But we need that in order to adjust it later when we put the actuals in, okay? And of course you can have a debt schedule. Now, there are a lot of extra little UDFs, user-defined functions, in here. 3 of them. There's one for the end of the quarter. So what, if you have a month by month, you can summarize it by quarter. But to summarize it by quarter, we're going to use the SUMIF or the SUMIF-S, and we need the end of each quarter so we can know that, oh, this is our criteria for the sum. And then we might want to just sum it only at the end of the quarter. So this says only when this thing, the end of the quarter is equal, the end of this month is equal to the end of the quarter. So this is, I guess, the start of the month. And I should put perhaps up here that that's what it is. Start of the month. Okay, and now to get this end of quarter, if we don't have that, then we can't go up and do a quarterly little summary. And the quarter little summary, that's easy to get once you put an end of the quarter in, you just use EO month and use 3. That's easy, but then we want to do a whole bunch of SUMIFs. I'm not going to go through all of this, but the true means it's going to be a flow number where you just directly add it. False means it's a balance sheet number. So when we have opening balance or remaining construction or upfront equity commitment or total debt, those are all falses because they're balance sheet numbers, and then you use the sum if else statement to do this. And of course you use the whole line. You click on the whole line and you can get either the balance sheet or the flow number. Okay, now once you have that, well, the EO quarter, let me get my thoughts a little bit straight. The EO quarter, I put a little thing here. It's a very easy function to do, but it's really, you could do this without it, but it would be a pain. It's kind of, you just say, here, give me a date, and after you give me the date, I need to know the month of the date. And then if the month is 147, then we have to go forward 2, and if it's 2, 5, 8, whatever, then we have to go forward 1. If not, we go forward 0, and when we go forward, we put EO month. That's not so hard. The second user-defined function is a user-defined function that says, okay, now I hope you're seeing kind of how this works a little bit, but let's pretend we have some actuals. And by the way, I made 3 scenarios of actuals. I just used a random number. I just put kind of our real, the summary that I just showed you, copied and pasted it, fixed the values, and then put a little variation around there, or simulation around there, and then we say, pretend this is our actual. But notice these are actuals for a quarter in this model, and that's probably very realistic. You get actuals for a quarter, but you want you want to put this month by month. So I said, well, why don't we just interpolate those? And of course, there's no interpolate function in Excel, so you've got to copy, go to the disk, or go to the Google Drive and go and find the interpolate lookup. It's right where all the generic macros are. And I said, let's use the linear method. And then we just gradually move it. And we gradually move it in between the months. And it works just fine. So it's just like lookup. We look up on the date. And then we say, okay, what's the date in the actuals? And then we look up for the work in progress balance, or I put a separate account for the I don't care, in interest during construction balance, and then the loan balance and all of that. So that's how all that works. Okay, so there's a second UDF. Now the third UDF is the big one. That's the circular reference one. And I thought, I'm going to really try this. Because there are so many circular references when you have this funding stuff. And then when you have the issue of putting the total cost of the project in and backing out how much debt you have to put into the project to get back to the 80%, circular references are a big deal. So I'm going to press alternate F8 and show you what I did. And it didn't work so badly, I promise. I just copied our template in, and I left, basically, I just left it alone. The template we made for 3 different debt issues, and you just kind of, I put a couple of comments around some of the places where we didn't use all the issues, the commitment fee, because we had an array, but it wasn't that bad. I swear it wasn't that bad. So then we don't have a copy and paste problem. Because the copy and paste in this one, I think, would be a mess. I didn't even try to do the copy and paste here. So those are the 3 user-defined functions: the EO quarter, the lookup, and using this template. And there are the videos. I made a bunch of videos. You have to be put up with a lot of torture to watch those ones, I'm sure. Then the main thing about this video is really how to make the adjustments for the actuals. And I've already talked about it. It's good to keep the actuals in a totally separate page. Don't type them over, please. Keep them in a separate page no matter what. And then there's an absolutely crucial step, which is to create a historic switch. And that historic switch, even though I showed it to you once already, so you put the date of the last historic period in here. And once you put the date of the last historic period, you make a little true and false switch that says, look at our basic date in the model that drives everything, and compare that to the last historic date and make a little true false. And that's so essential that I thought it was worth showing you again. And then we compute the implied values from the historic analysis. So what that means, oops, I didn't mean to do that. What that means is you go to the, you notice how I have to keep my thoughts kind of straight by making this little PowerPoint slides. We put all our actuals in here in somewhere, and then if it's the historic switch, well, then just the amount of construction is the difference in the work in progress. The amount of the IDC, only if it's the historic switch, the amount of the IDC is the difference. And same with the debt. The debt draws are the difference in the debt balance. Okay, so once you have the historic data in, you compute the draws, and then you have to create these accounts that have both historic and projected values. Some of them are easy. So if we go to the, I'm going through the debt schedule now, and when we go through the how many debt draws we have, just a minute. This is the projected, excuse me. We have the how much debt we have put into the, excuse me, this is the debt draws that is actually used. If it's the historic switch, well, we take it from the down there from the balance sheet that I just showed you. Otherwise, you just compute it as you normally would. And the way you normally would here is this says take all the remaining amount we have, all the funding we have, and put it against a debt to capital ratio. Okay, so what happened is here some actuals were different, and then once we finish the actuals, then we're just projecting it based on this flat 22.676%. And that's the same for the construction expenditures. Once you are past the historic switch, if it's the here's our final number. If it's the, I hope this is, if it's the historic switch, then just go down and take it from the balance sheet. Otherwise, use your revised S-curve that we're going to talk about in just a minute and multiply it by the revised S-curve. That's the way we can just change the dates around. Okay, when I probably change the dates around and put a little bit of different conditional formatting, sometimes you go back one page, and so there's our shorter period. That's if you, so the idea there, I should have been more clear about that. The idea is you can just add a new balance sheet every month, and you don't have to go typing in numbers. All you have to do is put the actuals here in this page. Okay, that's enough, hopefully, of the kind of method. And then, oops, this is in the way. I hope it wasn't too much in the way. If we're going to do the assets, the construction, we're going to revise the S-curve. And just a minute. Okay, so here's the example. I think I showed you these graphs, two different graphs, where you have the historic, and then you're going to, if you've spent too much, then you spend less in the projected period. Here's you spent too little, and then you spend more. So you match the EPC cost, and of course, what you can do as well, I shouldn't say of course, you could also then say, okay, in the middle of the construction, it's totally possible that the EPC cost, we had a change order or something, and it went up. Sorry, maybe it goes down. I don't know how. It could. We have contingencies, and we don't spend the contingencies. So we could put our new estimate of the EPC in, and when you get to the very end, it's just computed. So the next question is, how does this all work? The revised S-curve. I want to talk about how you get that. And essentially you take the original S-curve you had and then multiply that by not the true or false, not the true for the historic switch, but the reverse of the true. So you use naught. You use the naught function. And then you said, okay, well, let's take that total S-curve that happens after the historic period, and then add them all up. You have to add them all up. You use the sum command or sum product. You use sum with the shift control enter, and then you multiply all this by the remaining amount you have to construct. So you have the total EPC cost of 1,100 or 1,000 or whatever, and you have the difference between what you've already spent and that number, and you multiply it by the S-curve. So let's see how that works just for us in a minute. Okay, so here was our original S-curve. Okay, and we get to the end of the construction period, and you notice I have nothing here for the remaining profile because these numbers came from the balance sheet. And then you take this one and multiply it by not the construction switch, and multiply it by the S-curve, and then divide it by the whole thing, remainder of this thing. So you take the whole original S-curve and put a sum and put a naught there. That's how you do it now. If I change this date a little bit, okay, let's make it a little earlier. Okay, then we'll get a different number for that. Now it's 82%, and now all of our conditional formatting worked and all this. And then we have a different remainder that we have to spend. So this remainder is going to be applied to this new S-curve. Now to get the remainder, I think I have a little PowerPoint slide for this. We begin with the total EPC cost and subtract the balance. And here's the big deal. You hold it constant in the very last year. Okay, so let's start with the historic amount. So we have the total EPC cost. We see what's the balance of our construction. S159, let's find that. I'm very bad with that kind of. So this is the amount at the end of the period. Okay. And then you see, well, this is how much remaining we have to spend in the future, because we use the closing balance. It's the remaining in the future. And you get to this very last period, and then you put another if statement. If it's the historic switch, we'll make that calculation. Otherwise, just take the last one. So this just holds the remaining, for all the projected periods, holds the remaining flat. And that's a big deal. That's a big deal, is to use a different formula for the historic period and the projected period. Okay, so this was a little example of it. And now let's talk about the debt. Now for the debt, it's kind of the same thing. We have some, I already shown you this, we have some historic periods, and then we get to the end of the historic period, we take a remaining balance, and we have to either have to issue more debt or less debt over the remaining period to reach our target. And I accidentally turned the video on and off at the wrong point, so this is actually the second point. So I changed this debt percent to 82, but we could put it back to 80, and when you do this whole thing, that was the hardest part of making the model, and I'll tell you, it really did take a while. This was not an easy thing to really do. It's not an easy, this is not an easy one. And it's not easy because of the circular references. But when you get to the end, then this is the amount of debt we're trying to have. Oops, it's just calculating. And when we get to the end, the actual amount of debt that's in the model will be the debt we just aimed for. Okay, here's and I said end, I meant end of the construction period. And then I go down here and say, okay, after we issue the debt, then we'll repay it and do all the rest of the repayment stuff later on. Okay? Um, I thought I just changed this to 80. Well, I had to press the recalculate button. I'm not going to worry about that. I'm talking to myself. That's a little embarrassing. Okay, the big deal about this is getting the remaining funding and getting the percent. So what you look at me reading stupid little PowerPoint slides. We need to see, okay, how much is the total amount debt we borrowed? We're aiming for this 80%, and how much is left? And we take the amount that's left and divide that by the amount of construction or funding needs, really, including everything else. Now, I did this with a little example because this was tough. So I said, oh, let's make a really simple example because I was going around and around. So here we have 1,000, we have 700 that we're targeting for the debt, and 300 for the equity. And we have 2 historic years and 2 forecast years. And the actual debt balance here is this thing, and it doesn't match. This doesn't match the 70%. So when we get to the forecast year, we say, oh, okay, well, how much did we have at the beginning here? How much did we have at the beginning? And what's our total we're aiming for? And that we get the leftover, the remainder we have to fund. And then we can get our total amount of funding that we have, our total project cost, and see how much we've already spent, which is up here. So we've spent this much, and that means we have how much we have left to spend, which is the 400 here, really. That's the amount we have left to spend. So we see how much left of debt versus how much we left to spend. We're multiplying this by the amount of funding needs we have. This amount of funding we still have left to go, and we get 700 of debt. You add the actual debt plus the funded debt in this period, 81% times this, and that. So you had those. This illustrates the kind of thing you have to do. So here's what we got to do. We have to figure out the remaining amount of debt, and the circular reference issues are the pain here. And you could put a copy paste that God knows how many copy and paste you'd have to do to get this. Okay, but let me just kind of walk through the debt portion of it here. Okay, so we have the total project cost from our sources and uses statement, and then we're just switching between the actual and the forecast. We have the total amount of debt that we want, again from the sources and uses of funds statement, and then we do the same thing with the equity, and you take the total amount of debt, remaining amount we have to spend versus the remaining debt, and this is this number. It's almost the same sort of approach as the construction, and then as soon as you get to that last period, you hold it flat. You actually hold it flat in the period just after the first one. That's what was driving me crazy. It wasn't actually in the very first one, and then you apply that, and by the time you're all finished, you match the actual debt should match the target debt, and you go down and see that this balance of debt should be just the same as what you're targeting. Okay, and then you can just do it. And I guess I'll make one more comment. When we press alternate F8 and you copied this template in that had a lot of stuff in it, but the biggest thing I had to do was put a little historic switch. This is all, I almost shouldn't have shown you this really, but this says if it's the historic switch, then you can figure out the opening debt and figure out the remaining debt and divide it all. So you have to kind of do it by hand once, do it in Excel once, and then do it in this one, so you can avoid all the circular references and that just automatically add new add new historic statements. Okay, again, this file was built just because somebody in my class really wanted to do it. I think it's got a lot of complicated issues in it. It's a lot more complicated than I thought it would be. Okay, that's enough.